When professionals talk about project finance, they often trip over a basic definition. Risk is frequently treated as a synonym for physical danger or catastrophe, a fire, a flood, or a collapsing supply chain. International contracting classifies these physical events strictly as hazards. A hazard is the source of potential harm or the physical cause of a problem. The ISO 31000 standard provides a more rigorous definition. Risk is the specific effect of uncertainty on a project's objectives. An earthquake is a hazard. The subsequent 6-month delay and 20% cost overrun represent the risk. The physical reality happens in the real world, but the commercial effect is what hits the contract. Confounding these two terms prevents legal teams from actually protecting a project. You cannot allocate a physical event, you can only allocate its commercial impact. Because risk is defined strictly as the effect of uncertainty, it is not inherently negative. It encompasses both downside damage and upside opportunity. An unexpected geological finding during excavation might force a redesign that shortens the construction timeline. In this case, uncertainty has generated a highly efficient pathway. To measure these effects, we define a project as a unique set of coordinated activities designed to meet specific objectives. Success is achieved when those objectives are met within 3 strict parameters: schedule, cost, and performance. Contracting strategies focus on systematically controlling risk within these parameters, rather than attempting to eliminate uncertainty entirely. To understand risk allocation, we must map uncertainty against time. A project's risk profile is highly dynamic, shifting throughout its life cycle. Standard projects move through 4 chronological phases: development, construction, commissioning or startup, and operation. On the vertical axis, we track the fluctuating level of risk. During development, exposure is relatively low, but as the project moves into construction, where capital is deployed and physical execution begins, the risk profile peaks dramatically. As the asset stabilizes, the curve slopes downward through commissioning and flatlines into a predictable low plateau during the operation phase. While every project has unique features, this underlying bell curve timeline is the universal baseline. Financiers cannot draft a contract without first mapping exactly when specific project uncertainties are most likely to strike. To assign responsibility for these unknowns, we classify them into distinct categories. We need a taxonomy. Category 1 addresses exceptional events. These are uncontrollable variables, force majeure occurrences like acts of God, earthquakes, and epidemics. Category 2 covers political and governance risks, including expropriation, changes in law, embargoes, and corruption. Category 3 focuses on economic and financial risks, grouping currency devaluation, market volatility, and counterparty insolvency. Category 4 is execution. This is the densest bucket, aligning directly with the construction peak. It covers planning errors, design defects, and site access issues. Execution risks further break down to include supply chain logistics, labor disputes, and adverse weather conditions. This sorting algorithm transforms an overwhelming universe of unknowns into a finite, structured checklist of commercial terms. Once the risks are categorized, the central commercial question remains: which contracting party should bear the cost if things go wrong? The first rule is the asymmetry of mitigation. Different parties have fundamentally different tools to handle the exact same risk. A contractor physically on the ground is inherently better equipped to mitigate a supply chain delay than a distant project financier. The second rule is inherent risk attitude. Parties possess structurally different baseline appetites for risk based on their corporate nature and financial strength. The third rule is reward dependency. A party's willingness to accept risk is elastic. It shifts proportionally to the potential financial reward offered. Effective allocation means strategically assigning risk to the party best equipped to hold it, or most incentivized to manage it. Zooming out, we see the complete ecosystem of the project built throughout this framework. The construction contract serves as the physical, legal manifestation of this risk allocation matrix. These legal connections must respect both the temporal peaks of the project and the inherent asymmetries of the parties involved. Success is achieved only when this architecture keeps the schedule, cost, and performance parameters intact under the weight of uncertainty. By distinguishing physical hazards from commercial risks, mapping the temporal profile, and applying the axioms of allocation, teams gain control over the project's future. Mastering this framework enables legal and commercial teams to engineer mega projects that absorb and capitalize on uncertainty, turning potential failure into structured success.